Okay, inverse functions, we're going to make a couple of adjustments up here at the top. Some things we've done in the past. We're going to change our 5 concepts, you must know, down to 4. Because since we aren't doing compositions this year, because we got to eliminate part of our other notes with this too, using compositions to prove inverses isn't really going to help us very much. So we're going to be down to 4 concepts, and we're actually going to discuss all 4 of them today. To find the inverse of something, you switch the x and the y, or you then can solve for y. I better put sometimes in here, because there's going to be sometimes we're going to do that and sometimes that we aren't. So we'll talk a little bit about that. The domain, we're like, oh yeah, domain is x values. And the range switch, we'll talk about that a little more in depth. To graph the inverse, you can reflect the original over the line. And there's another way too. We're going to take a look at both. And then passing the horizontal line test if you have a graph. So we're going to talk about those a little bit here and work our way through them, but there's lots of ways we can use to prove. Okay, easiest one. We'll start with the easiest one. To find the inverse, you switch the x and the y. So basically all I'm going to do is I'm going to take all these x values, I'm going to move them into the y row of my chart, and all my y values are going to switch onto here. And you're like, now why would that be? Because if we were looking at this graphically, if we actually had the equations of these, they would actually make kind of a mirror image of each other. And we're actually going to see that in a little while. But whenever you see a graph, basically you're just going to take the x and y's and flip them, invert them. So you're like, okay, that's not so bad. Now if you have it in an equation form, like we do here, now this one's a little bit of a process, so stick with me. Okay, here's my original. What I want to do then is I'm going to switch the x and the y. Okay, sort of like what I did when I was doing with the numbers up above, except now I'm actually doing it with the literal variables. But here's the kicker. Once you switch, I'm going to go ahead and I'm going to solve each of these equations for y. So let me kind of put this in a step. I guess this would be my second step. My first step would be to switch x and y, which we just did anyway. So get them switched. And once you get them switched, your job becomes get y alone. Well, I guess I got to get 2y alone first. So what do I need to do first to start working on isolating my y? Add the 4. Get that taken care of here. And then one step to go. Divide by 2. Now some of you are going to write your answer differently, and I don't care which way you do this. When we get to the inverse of something, we signify that by saying it's y to the -1, like you'd say if you were going to flip something. That doesn't mean I'm going to flip anything, it's just a label. You can either write it exactly the way you see it right now, x plus 4 over 2, perfectly fine. Or if you were looking to graph it, you could put a 1 in front of your x, and then 4 divided by 2 is 2. Either one of those works. If I were graphing, I would suggest doing it as 1/2 x plus 2, because that's more like what slope-intercept form would be. But if you're just being asked to find the inverse, either one of these is fine. And normally I signify with the y to the -1. If you forget that part, that's not a big deal. But what you'll see, because I want to show you one of these so you can visually see why they're inverses, and we'll do this again in a little bit. So if I were to graph both of these, if I were to graph 2x minus 4, and then on the same graph my 1/2 x plus 2, what you'll find is there's this line called y equals x. It's basically just a, let's get that in here too. Y equals x is the line they reflect on. So let me do a little explanations here of things. You're like, holy crap, Harty. Okay, here's what's going on. this diagonal line that you see right here in the middle, if I were to use that as like a dotted line, and I were to fold my paper up upon that line, I'd get an exact reflection. Like this point would reflect with this point, and this one reflect with this one, and so on. That's how these are always going to work as far as those go. So visually, I'll be able to start seeing after a while if I'm doing things correctly, because I'll see, oh, I see those reflections going on. But we're just doing it algebraically right now. So with these, same thing every time. Switch X and Y. And then start working on getting Y by itself. Now I'm curious to see how some of you might want to take your next step on this one. Any ideas? What's that? Okay, I like that idea best because then we're not dealing with the fraction until our Y is isolated. Okay, and that would be my suggestion. He said multiply by the reciprocal. Now some of you are more comfortable multiplying both sides by 3, getting that worked out, and then dividing by -2. And that's fine. But the quicker way would be to go ahead, I wish I had more room next to my equals, but I'm going to put it over here instead, is to multiply through by the reciprocal. Basically, I'm just flipping the fraction over. Because then those will cancel each other.
Is it still negative? Is the reciprocal?
Yeah, because I need the negative times negative to get that Y by itself. And I'll show you the other way too. And then I just would distribute that -3/2 through. So I'd have -3/2 x, and then -3 times -6 is 18, divided by 2 is 9. That would be what I'm working with. Now, like I said, and I'll put it here next to it so you can kind of see, if some of you got to this step that we were at originally and said, okay, I don't like this reciprocal thing, it drives me crazy, I'm going to do it one step at a time. That's okay. You could say, okay, I'm going to multiply both sides by 3, so I had to get rid of the fraction part over here. So 3x minus 18 equals -2y, and then I divide through by -2. And I get the exact same answer. So there isn't a right or wrong way. Well, that's faster, so I have to do it that way. Not if it messes with you. Not if you have issues with fractions. If you have issues with fractions, take it one step at a time, get to the right answer. It's more about getting to the right answer than it is being fast. So that's one thing we got to keep in mind. So then, when I get to this next one, we get a new little twist that comes in here. I'm just going to move this one over here. Our new twist, once we switch x and y, is now we have a squared term to play with. But my first job always, always, always is to isolate my y term before I start doing anything fancy. And this is where we've struggled a little bit. So no square rooting both sides until that y term is completely alone. So once I get to here, don't square root yet. Yep, got to divide first. And some of you are probably going to like having it written out separately. Some of you are going to like the fraction. I'm fine just leaving it as a fraction for right now. So then, I have to square root this to get rid of the squared. What always happens with my answers when I take a square root since I have y squared? What has to go in front? Yeah. I have to remember plus or minus. Because if I don't, I'm only going to be getting half the solution.
You simplify that even more, like x divided by 2 minus 4, and then square root of 4, and just have the square root of x.
No, because that's a good question. So if I decided that I was going to simplify this, okay, let's take a look at that. So if I decided to turn this into 1/2 x minus 4, and I took the square root, Could I break down the 4 more? And the answer is no, and here's why. Whatever I'd be able to break down, I'm going to need to break down everything in here, not just a piece of it. So if I did write it this way, I could with my plus minus, but as far as getting that down to 2, nope, can't do it. Can't do it. And the fun thing about seeing this one, and where I think some of you that are more visual learners, hopefully this is going to click more, even though we're going to get to graphing later, this is one I always like to let students see because I think it actually reinforces this a little better. So if I were to look at the graphs of these, because again, we get that mirror image that I talked about, this one really shows it. So if I type in 2x squared plus 8, now I'm just going to look at that first. Okay, it's a parabola, it's this little tiny guy up here. I'm going to change my window a little bit so you can see him a little better. Let's change that to 20. Okay, so there's my first one. So this next one, when I type it in, let me show you what happens if I forget. You're like, how do I do plus minus? Just watch. So I do square root, and again, I can do it either way. Probably better here if I use 0.5x for 1/2. Because again, pull this back up for a second. 0.5 is like 1/2 x minus 4. And I graph this. You're like, wait a minute, I just see this little tiny thing over here. All right, let's shrink out a little more. You're like, but I only see half of it. That doesn't look like a reflection of this. That's like a parabola. That's not right. Because right now I've only got the positive of this. If, and again, I'm just showing you, I'm not going to make you do stuff like this all the time, but sometimes seeing where things actually come from lets you see a little more on why we do it. That got me the other half of my parabola. So these end up being mirror images when I get that line going through. Just something to ponder a little bit. And then we have to do one more that's nasty with a fraction. All right, switch them. This time we're going to do what's best for the group. For most of you, seeing double fractions there is going to drive you nuts. Let's get rid of that first. So we're going to multiply all the way through here by 5 to dump this. So it goes to the x, even though it isn't a fraction, and to each of these. So as I start to work my way down, 5 times 2 is 10, divided by 5 is 2, so 2y, because again, it's basically just canceling the denominator on each of those. And for most of you, that's a lot easier to work with than continuing to work with the fractions. So let's see. I'm rid of the fractions. What should I do next?
Add 4.
Add 4, because I need to isolate my y term. And then to finish it off, we're just going to divide by 2. And again, if you want to leave it this way, that's fine. If you want to break it down and have the 2 there, and 4 divided by 2 is 2, that's fine. It's your call on that. But we're just using algebra to find the inverses of these particular functions. So switch x and y, solve for y, you're done on those. Now back to easy stuff. The inverse is a function. If the original passes the horizontal line test, which way does the horizontal line go? Okay, side to side. So if I draw a horizontal line anywhere through the function I see, that tells me if it only goes through one place, that its inverse would be a function. If I draw that horizontal line through and it goes through lots of points in the graph, yowzers. Okay, that gets my point across. Any more than one point that it goes through, it's going to be no. Their inverse would not be a function. So if I were to draw the mirror image of this, it would not work along that line. But again, anywhere works. If I only get one, it's a yes, and I keep going on. So anytime you see a graph and you're asked if its inverse would be a function, you run the horizontal line test, not the vertical, because those are two different things for two different purposes. All right, let's see what else we got here. Okay, now I need you to, let me grab one thing here. I didn't have a back page on mine. All right, now we are not going to do compositions. We're going to change the directions here a little bit. Does the inverse of f of x equal f sub negative 1 of x? In other words, if I find the inverse of f of x, do I get this back? If I do, they are inverses of each other. If I don't, they aren't. Okay, so the rules are the same as they were in that last section. I'm going to take this one. Remember, f of x is just a fancy way of saying y. So, my first step is to switch x and y, and then work on solving for y. So again, I want to isolate my y term. And then once my y term's isolated, I just divide to get that done. Now, some of you may look at this and go, nope, they're not the same. But again, it may be in a different format than you normally simplify to. Bless you. So here, 1 over 2, well, that's going to be a fraction. It'd be 1/2. But 4 divided by 2 is 2. They're the same thing. These guys are inverses. What's that? Okay, all I did here was I took this one, I switched. Okay.
But I got x minus 4 over 2 equals y.
X plus 4 over 2?
Yeah.
Okay. So what I'm doing is I just basically took this and I broke it apart. I said, okay, so 1 divided by 2, that doesn't go in evenly. It's going to be a fraction. So 1x over 2 would be like 1/2 x. 4 divided by 2 is 2. These two things, x plus 4 over 2 and 1/2 x plus 2 are one and the same. Because all I did on this one was I took each piece, so 1x over 2 is like 1/2 x, and 4 divided by 2 is 2. It's just two different ways of looking at the exact same expression. And that's how I found out those would be the same. So for any of these, if I switch the x and the y, go ahead and get my y solved for. Sometimes I'm kind of looking, I'm like, yeah, this doesn't look good. Is this? Yeah, no, it's not. So if your first doesn't equal your second, once you find your inverse, you go through the steps, they're not inverses of each other. But we always want to make sure I'll minus my 20 over. And then divide by 5. And again, sometimes they may stay in this form, but if they break them up, we have to be able to break them up. Put a 1 here in front of my x. So 1 over 5x, and negative 20 divided by 5 is negative 4. Those guys are the same. We're good. Now 12 is the tricky one. 12 gets a little bit tricky. Well, you'll see here in a minute. Because we're going to have to play with some exponent rules here. So I'm like, okay, the -5 part's not bad. It's this next step that I'm really going to have to watch myself with. So here, how do I get rid of something that's cubed? Close. Normally if it was squared, we'd square root it. So since it's cubed, yeah, we're going to cubed root it. And yes, they are the same. So little things like that may pop up too occasionally. So, something to watch out for. And then the only other thing we're going to get into is a little bit more in-depth analysis a little bit. Find the inverse of the function. Okay, got this. X equals y squared. What's my one step to get y alone in this one? Square root it. Now, here's where I've got to watch it a little bit. Because I look at this and I'm like, okay, it's got this, you know, why does this only work when x, ooh, Harty, plus minus, bad. Why does this only work when x is greater than or equal to 0? What would happen if I put it in negative?
Put a negative would still be positive. Negative times a negative is positive. It's still the same.
For x in this case, let's see. Because this is the inverse. It's the inverse that I'm kind of testing out here. So let's get out of here. So like, let's say I took the square root of, I don't know, -4. When I'm looking at these, we know we could take an I out if we had a negative that went in there. But the calculator, we're not going to be able to get a real answer out of this. So when we talk about why does it only work when x equals 0, because if x is less than 0, we end up with imaginary solutions. And I can't graph imaginary solutions anywhere, and all of these are going to be graphable. So if I get anything that would get me I, and again, without the restriction, I could. So I've got to make sure it stays positive to keep that going. It's sort of like our domain rules from a couple of sections ago. So those are the little type things I have to keep an eye out for. Keep an eye out for. Okay. So again, f of x is just a fancy way of saying y. We switch the x and the y around and go to work on solving for y. And again, don't mess with that exponent until y is completely isolated. And just like we had up above in number 12, since I'm trying to isolate a y cubed, I use the cube root, and I have to remember that little 3, because otherwise it's a square root, and that wouldn't take care of it for me. Looks weird, but that would be my inverse. The only time I end up with having to have the plus minus is when I've got a quadratic, like something that's squared, something to an even. Good question. Yeah, with the cubes, I do not need the plus minus. Only the squares when I'm doing those. And then I'll even say, just some previews to possible future quiz questions. Explain how to use the horizontal line test to determine if an inverse relation is an inverse function. Real simple. If it passes through, one point, the inverse is a function. And I guess I should put the word only in here. Like if it passes through 2 or 3 or 4 or 5 points, nope, not going to work. If it passes through 1, it absolutely positively will. Thank you. Oh, let's see here. Describe how the graph of a relation and the graph of its inverse are related. Well, there's a couple of things. One thing you could tell me is about how x and y are reversed. You also could say y and y sub negative 1 are reflections, because we took a peek at what they'd look like a little bit when we were graphing them. And then I'll let you guys tell me on this last one, because it's pretty quick and pretty simple. There's only 2 steps. How do you find an equation for the inverse of a function? What 2 things have we been doing? Like, oh, switch x and y.
But then you just solve it.
Solve what? Solve for which variable? Y. Now, anything question-wise? Because as I mentioned before, this guy, oops, let me flip over on the other one. Now I got double sheets going here. Here we go. This guy, homework check 12, number 2. Let me stress again. You need to do these today for 2 reasons. Number 1, so you don't procrastinate. Number 2, this stuff is on the quiz. On the quiz coming up, like the one for Wednesday. So you can get this up. I'll have the key up here tomorrow. I'll have the answers in.